Solving systems of linear equations by substitution. All right, so our state standards, here's our success criteria. Solve a system of linear equations by substitution. Solve a linear equation in two variables for each variable. Solve real-life problems using substitution. So we need to be able to solve every type of system of equation in this lesson. All right. Key idea, solving a system of linear equation by substitution. Solve one of the equations for one of the variables. Substitute the expression from step 1 into the other equation and solve for the other variable. Substitute the value from step 2 into one of the original equations and solve to find the variable of the value of the other variable. All right. Let's see what example 1 says. Example 1, solving a system of linear equations by substitution. All right, so if we look at the system, we have two equations. That's why it's a system of equations, because we have two or more linear equations. The first one is y equals negative 2x minus 9. So it's already solved for y. So using substitution, we can take negative 2x minus 9 and substitute in 4y in the other equation. So I can take this part right here and I can plug it into my y value in my other equation. So we're going to substitute negative 2x minus 9 into the y for the second equation. So if we do that, we're going to have 6x minus 5. In place of y, we're going to put negative 2x minus 9. And then the rest of this equation is equal negative 19. And then from here, we can solve. So bring down our 6x. We can distribute the negative 5. So negative 5 times negative 2x is plus 10x. Negative 5 times negative 9 is positive 45. And that equals negative 19. Now, like terms can be combined. So 6x plus 10x makes 16x. And then I'm trying to solve for x, so I'm going to subtract 45 from both sides. All right, and I've got negative 19 and negative 45, so that will be negative 64. And I'm going to divide both sides by 16. And that's going to give me negative 4. All right, so I substituted this expression in for this equation, and I solved for x. Now we have to solve for y. So we're going to take our x, our value of x, and we're going to plug it in to either equation. Since it says y equals this, the first equation would be the most logical to substitute in. So y equals negative 2. Now we're going to replace x with negative 4, and then we're going to have minus 9. So negative 2 times negative 4 is positive 8. Positive 8, bring down the negative 9. 8 minus 9 is negative 1. So that would be our y value. So our solution would be negative 4, negative 1. And just like with graphing, we need to check our solution by substituting it into both equations to make sure it works. So let me change colors here just to show that it is what we're doing to check it. All right, so number 1 says, or equation 1 says y equals negative 2x minus 9. All right, so we're going to substitute. Remember, this is our x and this is our y. So our y is negative 1. Does that equal negative 2 times negative 4 minus 9? All right, does negative 1 equal negative 2 times negative 4 is positive 8. 8 minus 9 equals negative 1. So that one does work. So the solution works for the first equation. Now let's plug it in and check it for the second equation. All right, let's use yellow. All right, so we've got 6. This time we're going to plug in negative 4 for x. And we've got minus 5y. Y is negative 1. And we want to know, does that equal negative 19? So we've got 6 times negative 4, that's negative 24. And then negative 5 times negative 1 is plus 5. And does negative 24 plus 5 equal negative 19? It does. So negative 19 equals negative 19. That works as well. So what we know is that the solution negative 4, negative 1 works for both equations. So negative 4, negative 1 is our answer. So negative 4, negative 1, that's our answer for this system of equations. So we did that using substitution. If you wanted to graph these two equations like in the previous lesson, you would be able to check that as well and see that those cross at negative 4, negative 1. All right, example 2, solving a system of linear equations by substitution. Again, we have a system because we have two equations. This time we have 3x equals y plus 8. We have 3x plus 2y equals negative 1. So let's solve this for x. So we can simply divide the top equation by x on both sides. So 3x equals y plus 8. If we divide by 3, we have to divide everything by 3. And that gives us x equals 1/3 y plus 8/3. Now, that's not the only way to do it. And since we ended up with fractions there, may make it a little bit harder to substitute for some of you guys. So if you look over here, it says there's another way you can do it. So you can also begin solving the equation for y, then substitute into the other equation. So even though y is on the right side of the equation instead of the left, let's go back and solve for y instead of x. Now, sometimes it may be easier to solve for x, and you can get the same answer by doing what we just did, but it may be a little easier if you do without fractions. So 3x equals y. I say a little easier. Sometimes it's easier to make less mistakes if you're not dealing with fractions for some of you guys. All right, so y equals 3x minus 8. And now we can substitute this part, y equals this, so we can substitute that into our second equation here for y. All right, so we're going to go 3x plus 2y equals negative 1, and we're going to replace the y with this expression here. So now we're going to have 2 times 3x minus 8 equals negative 1. So what that does is it eliminates one of the variables because we substituted this in place of y, and this is in terms of x. Now we have an x and an x. When you only have one variable, now you can find what that variable is equal to. So 3x, then we're going to distribute the 2. 2 times 3x is 6x. 2 times negative 8, negative 16. And that equals negative 1. Again, we have like terms. 3 and 6 make 9x. Now we're going to add 16 to both sides. And divide by 9. All right, 15 and 9 are both divisible by 3, so we can simplify that, and that will simplify 3 goes into 15 5 times, and 3 goes into 9 3 times, so that's going to be 5/3. All right, so now we have our x, so now we have to find y. So we're going to plug x into one of these equations. Since we already solved this for y, that would be the simplest way to do that. So I'm going to flip this around. I'm going to put y on the left side. So y equals 3x minus 8. So y equals 3 times 5/3 minus 8. All right, so that's the same as 3 over 1. That will reduce. So y equals 5 minus 8. 5 minus 8 is negative 3. So our x is 5/3 and our y is negative 3. Notice that I always put the ordered pair as xy. You always list your ordered pair as xy no matter which value you solve for first. You always write your ordered pair as xy. All right, now we need to plug these in and check them. All right, so let's do 3 times x. X is 5/3. Does that equal y, which is negative 3, plus 8? All right, again, I can write this as a fraction. I can reduce that. That becomes a 5. Negative 3 plus 8 is 5. So 5 equals 5. So 5/3 and negative 3 is the solution for the first equation. Now we got to check the second equation as well because we're trying to see if it's a solution for the system. So we're going to have 3 times x. All right, 3 times x plus 2 times y. Y is negative 3. Does that equal negative 1? All right, again, this cancels and gives me 5. 2 times negative 3 is negative 6. 5 minus 6 is negative 1. Negative 1 equals negative 1. So that works as well. So what that means is that 5/3 and negative 3 is a solution to both of the equations, which means it's a solution to the system of equations.